Hello and welcome to Psych319. This is Chapter 4, Part 1, Object Perception. Um, Before we get into the actual parts of object perception, we have to talk about perception in general. So I'm going to introduce you briefly to the sensory systems. Most of us are probably acquainted with the five senses: vision, hearing, olfaction, which is your sense of smell, gustation, which is taste, and somatosensation, which is your sense of touch. There's actually a sixth sense, and no, it does not involve the ability to see dead people, and it's not common sense. It's called proprioception, and proprioception is your sense of balance and body awareness. Um, so in general, there's a lot of shared properties between all of these senses. Their main job is to take energy from the outside world and convert it into neural impulses. That's energy your brain can understand. Um, so vision converts light into neural impulses, and sound audition converts sound pressure waves in the environment into neural impulses. So in a sense, we're always taking sensations, which are we're taking the physical world and transforming it into a perception. So in sensation and perception, there's a very clear distinction between sensation and perception. Sensations are the detection of physical stimuli via the sensory receptors, and perceptions are interpretations of those sensations. Um, and while those things sound very similar, they're actually quite different. I want you to think about the pressure your shoes are putting on your feet right now. You didn't notice that until I directed your attention to it. The sensation has always been there, but because now I've directed your attention to it, you've created a perception out of it. And so attention is necessary for converting sensations into perceptions. Um, we bring a lot to any stimulus that we're looking at in the world. So, for example, take a look at the cube shape up on the right-hand side of the screen. It's called a Necker cube, and you can flip the perception of that cube into two different ways. You can either see the gray shaded surface as being part of the back of the cube, or you can see it as being part of the front of the cube. And when you try and switch your perception between those two states, the orientation of the cube will switch. Now, of course, this is all in your mind because the physical stimulus is not changing at all. There's no change to the slide. It's just standing there. And beneath that, you might see some gray shapes on a white background. And so ask yourself, well, what are those shapes? What do they mean? Now, a few of you might have gotten this, but I'm going to give you the answer. It's actually the word tie, like in necktie. And the word is written in white. I think I can actually draw this out for you. That's a T, an I, and an E. And you may have missed that because you were focused on the gray shapes, perhaps, as being part of the foreground rather than the background. So again, the brain can interpret a stimulus in various ways, and that's kind of the beauty of perception. Again, in general, this slide just shows we're taking stimulus energy from the outside world, whatever that is. It falls upon our sensory receptors through the art of transduction, which I'll get to. We convert those energy waves into neural impulses that the brain can understand. So transduction is the transformation of physical energy into nerve impulses. Sensory receptors are cells in the periphery that perform transduction. And according to the doctrine of specific nerve energies, different sensory modalities exist because signals received by the sense organs stimulate different nerve pathways leading to areas of the brain. And so what this really means is that you perceive things as sight because they're connected to light detectors. If we were to rewire your brain and connect the parts of your brain that are responsible for vision to your ears, then suddenly you would see sounds. So it depends upon what energy is being converted and where it ends up in the brain. And there's a very bizarre condition called synesthesia. And some of you, it's very rare, but some of you may actually have this. And this is the idea where two parts of the brain become cross-wired. And so for the most part, the person sees and hears quite normally, but there's some conditions where a person might actually see sounds or hear colors. So for example, they might see a number on a screen, but every time they see the number 3, it looks kind of blue to them. You can find out some more about this on the internet. There's plenty of information written on it. But again, it's just to show you that your perception is a function of what it's connected to, what your brain is connected to, and what part of the brain is receiving that information. So I'm going to stop briefly here, and then we'll continue in the next set of slides.